Hello friends, welcome to my second video about fraction. In this video, we'll talk about equivalent fraction and we'll do some problems regarding the equivalent fraction. So let's get started. Equivalent fractions are fractions that have different numerators and denominators but are equal to the same value. Let's explain through a model. I drew a circle before. Now I am making 4 equal parts and I am doing this using dotted line to do that. 4 equal parts and I'm shading one of them. So as we learned in my first video, the fraction of the shaded part is 1 by 4. Now I am making the same circle with 8 equal parts. So I'm joining the dotted lines together with the additional 4 lines to make 8 equal parts. We'll definitely count after I'm done. 1, 2, 3, 4, 5, 6, 7, 8. Now, if I tell you how many parts are shaded, you will say 2. But the fraction of the shaded part will be 2 by 8. So the same fraction, which was 1 by 4, is equivalent to 2 by 8. So both are equivalent fraction. Let's do another example. This time, I will make this rectangle to the 10 equal parts. If I make 9 dotted lines, that will give us 10 equal parts. Let's do 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now I'm shading 4 of them. And if I ask you, what is the fraction of the shaded part? It will be 4 by 10. Next, we are pairing two parts in this rectangle and consider is 1. So these two dotted parts considered 1. These two dotted parts will be considered a 2. These two dotted part would be considered 3. These two dotted parts will be considered as 4. These two dotted parts considered as 5. So how many parts are there? The line 1 with two dotted parts make one solid line. So how many parts are there that makes a solid line? 1, 2, 3, 4, and 5. So 5 will be the denominator. And how many parts are shaded? 1 and 2. So 4 by 10 is equivalent to 2 by 5. So if you see this case, the value has increased, but in this case, value has decreased. Here, we started with 1 by 4. With a dotted line, we make it 8 equal parts with a solid line, and that gives us 1 by 4 is equal to 2 by 8. Here, we started with the 10 dotted lines. Next, we pair up with the two dotted parts as a one solid part, and that gives us 5 solid part, and 2 of them are shaded. So 4 by 10 and equal to 2 by 5. So we can see in equivalent fraction, the value could be increased, the value could be decreased. But both the case, the value of the two fractions are same. Let's put that in a number line. I'm explaining the equivalent fraction on a number line. This is a number line 0, 1 and 2. First, let's partition the number line into halves. When it's halves, the denominator will be 2. And I am using the pink line for halves. This is 0. Between 0 and 1, if we make one line, that gives it 2 equal parts. Between 1 and 2, if I make one line, that gives you 2 parts. I'm boxing the whole numbers. So this is 0, that is 0 by 2, 1 by 2, 1 means 2 by 2, 3 by 2, 4 by 2. Now, the same number line I'm dividing into fourths. Fourths mean the denominator will be 4, and I'm using a green pencil for that. We can do it in an easier way. So each part between 0 by 2 and 1 by 2, if we make one line, between each half, if we make one line, that will give us 4 part between 0 and 1. 1, 2, 3, 4. 1 to 2, between 1 to 2, 1, 2, 3, 4. So let's put the fractions. 0 means 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4, 5 by 4, this green line, 6 by 4, 7 by 4, and 2 means 8 by 4. I'm darkening this one. This is a pink line as well as green line. Now, the same number line we are partitioning with 8s. 8 means the denominator will be 8. So 0 means 0 by 8. And between each 1 by 4, I am making a line which is purple that gives us 8 equal parts between two whole numbers. Let's put the fraction. 0 means 0 by 8, 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8, 1 means 8 by 8, next is 9 by 8, 10 by 8, 11 by 8, 12 by 8, 13 by 8, 14 by 8, 15 by 8, and 2 means 16 by 8. Now, look at the number line. You see 1 by 4 and 2 by 8 in the same number line. Same, 2 by 4, half, and 4 by 8 are in the same number line. That means a same location. 3 by 4 and 6 by 8 is locating in the same location. 4 by 4, 2 by 2, the whole number 1, and 8 in the same line, in the same point. 5 by 4 and 10 by 8 are sitting together. 6 by 4, 3 by 2, and 12 by 8 in the same line. 7 by 8, I think this would be 7 by 4, sorry. 7 by 4 and 14 by 8 in the same number line. 8 by 4, 4 by 2, and 16 by 8 in a same number line. And number 2. Let's write it down, all the equivalent fractions. 1 by 4 and 2 by 8 are equivalent fraction. 2 by 4, 1 by 2 and 4 by 8 equivalent fractions. 3 by 4, 6 by 8 both are equal in values. 4 by 4, 2 by 2 whole number 1 and 8 by 8 have same values. 5 by 4, 10 by 8 are the same values. You can also box it 6 by 4, 3 by 2 and 12 by 8. You can write down and put a box so that for your understanding. Now, we'll be having some example and we have to tell whether it is equivalent or not. For example, 4 by 6 and 2 by 3. So the simplest form of 4 by 6 is 2 by 3 because 2 is a common factor between 4 and 6. So both are, see, we got 2 by 3 here. The second fraction is also 2 by 3. So they are equivalent. 7 by 2 and 21 by 6. So 7 by 2, there's no common factor between 7 and 2. But between 21 and 6, the common factor is 3. 21 divided by 3 is 7. 6 divided by 3 is 2. See, we get both fractions are equal. So yes, this is also equivalent fraction. Next, 12 by 8 and 6 by 5. There's no common factor between 6 and 5. But there is a common factor between 12 and 8, which is 4. 12 divided by 4 is 3. 8 divided by 4 is 2. See, we got 3 by 2, that is the simplest form of 12 by 8. And the other fraction is 6 by 5. So they are not equivalent. Not equivalent. Let's move on to the next topic. So when we multiply or divide both numerator and denominator of a fraction, which we call parent fraction, with same number, the resulting fraction becomes an equivalent fraction of the parent fraction. For example, 2 by 3, if we multiply numerator and the denominator by 4, it becomes 8 by 12. So 2 by 3 and 8 by 12 both are equivalent fraction. Another example, 16 by 20. The greatest common factor between 16 and 20 is 4. So 16 divided by 4, 20 divided by 4. 16 divided by 4 is 4. 20 divided by 4 is 5. So 16 by 20 and 4 by 5. Both are equivalent. So we can see the numbers could be increased, the numbers could be decreased. So when the increase in the number, so the clue is that means some digits definitely multiplied in both numerator and the denominator. If the number decrease, that means one digit, same digit actually, divided by both numerator and denominator. So when the increase in values, that means some digit is multiplied, and when the value decrease, something must be divided. Let's have an example. Four by 5 equal to 16. But what number? The box. We have to find the missing number in the box. Now look at this problem. 4 becomes 16. So definitely a digit has been multiplied. So if you divide 16 by 4, it is 4. So 4 times 4 is 16. That means the digit which is multiplied is 4. And 5 into 4 is 20. So the missing number in the box is 20. We will review a couple of this example at the end of the video. So keep watching the video. So let's try another example to put the equivalent fraction in a number line. This is our number line 0, 1, 2. Let's partition with thirds. That means the denominator is 3. So between 0 and 1, 3 parts. 2 lines make 3 parts. 1 and 2, 3 parts. 2 lines make 3 parts. 0 means 0 by 3. This is 1 by 3, 2 by 3. 1 means 3 by 3, 4 by 3, 5 by 3, and 6 by 3. Now the same number line I am partitioning with sixth. 6 means the denominator is 6. 0 means 0 by 6. And I am making 5 dotted line to make 6 equal parts. So if I put each a dotted line between each these two solid line of 1/3, it will ultimately give you 6 equal parts. Let's count 1, 2, 3, 4, 5, 6. Yes, we made dotted line between each 1/3. That will give us 6 dotted lines and 6 parts. We keep doing that. Okay, so let's put the fractions. 0 means 0 by 6, 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 1 means 6 by 6, 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6, and 12 by 6. Let's find out the equivalent fractions. Same line, 1/3, 2/6. Same line, 2/3, 4/6. Same line, 1, 1, 3 by 3, 1, and 6 by 6. 4 by 3, and 8 by 6. Same line, 5 by 3, 10 by 6. Same line, 6 by 3, 2, and 12 by 6. Same line. Let's put in the box. 1 by 3 is equal to 2 by 6. 2 by 3 equal to 4 by 6. 3 by 3, 1, and 6 by 6. 4 by 3 and 8 by 6. 5 by 3 equal to 10 by 6. 6 by 3, 2, and 12 by 6. Same line. So by dividing the same number line by thirds and sixths, we found 1, 2, 3, 4, 5 equivalent fractions. Let's review one more time to find the missing number. Let's look at the first example. 4 becomes 16, and we have to find the missing number in the box. Something becomes 36. So if we think about 4's table, 4 times 4 is 16. So the digit has been multiplied is 4. Same rule, because equivalent fraction means multiplying or dividing numerator and denominators with same digit. So what time 4 equal to 36? So we know 9 times 4 equal to 36. Let's move on to the next example. See here, the value decreased. And when value decreased, that means this value has been divided by a digit. So if you think about 11's table, 11 times 5 is 55. So the digit which has been divided is 5. 75 divided by 5 is 15. Next example, 7 become 14. Value increase, something definitely will multiply. 7 times 2 is 14. Same rule, because both are equivalent fraction. What times 2 equal to 26? 13 times 2 equal to 26. Now look at this one. 36 become 9, but there is nothing in the denominator. Always remember, if nothing in the denominator, we can consider the denominator is 1. So 36 become 9. So something definitely being divided. If we think about 9's table, 36 divided by 9 is 4. Check one more time if that works. 36 divided by 4 equal to 9. Yes, it's working. Same rule, something divided by 4 is 1. 4 times 1 is 4. Or you can say 4 divided by 4 is 1. So the missing number is 4. Go to the next example. Again, the value decreased. 28 becomes 7. So something definitely divided between numerator and denominator. If you think about 7's table, 7 times 4 is 28. So the missing number is 4. So 4 is the digit that divided both numerator and denominator. 12 divided by 4 is 3. Next example. Again, 10 becomes 5. So something definitely being divided. So find the missing number. 10 divided by what? Equal to 5. So see, 5 times 2 equal to 10. So the missing number will be 2. Same rule, top and bottom. 10 divided by 2 is 5 and 24 divided by 2 is 12. Thank you for watching this video. Stay tuned. In my upcoming video, we'll talk about more about fraction and other things. Thank you.